Hello dear student, today I am going to discuss the classification of local anesthetics. Local anesthetics are the drugs which are applied on the external surface of our body in order to perform minor surgeries. The classification which I will discuss today is completely based upon the chemical nature or chemical composition of that particular drug. The characteristic feature of local anesthetic drug is that most of the drug, not all drug, most of the drug have this N-N-diethylamine group in its structure. So this is the characteristic feature of local anesthetic. Previously we have discussed in antihistaminic the drugs, antihistaminic category drugs have N-N-dimethylamine group, and here N-N-diethylamine group is present in most of the local anesthetic drugs. So let's begin the classification of local anesthetic. The first class of local anesthetic category is esters of benzoic acid. Ester of benzoic acid. Ester of benzoic acid again divided into two classes. The first class is natural agent. Natural agent means those components which are naturally present in our environment. So what is naturally occurring substance which act as a local anesthetic is, the example is cocaine. Let's see the structure of cocaine. As cocaine comes under the class ester of benzoic acid, so here first this is your benzoic acid, and cocaine is the ester of benzoic acid, so there is another R group present over here. So what is that R group? So it is nothing but this 8-membered cyclic ring is there, and here C double bond O CH3. This is the structure of your cocaine. This is methoxy group, and this is carbonyl group. So methoxycarbonyl group is present on this 8-member cyclic ring. This is your cocaine. Now second category is synthetic agent, and the best example of synthetic agent is hexylcane. Which one? Hexylcane. And what is the structure of hexylcane? So again, hexylcane comes under the class ester of benzoic acid. So first this is your benzoic acid, and hexylcane means it have hexyl ring in its structure. So where this hexyl ring is present? So hexyl ring is present in this way: CH2, CH3, and here another NH group is present, and on this NH group there is hexyl ring. So this is your hexyl ring. So that's why its name is hexylcane. So this is the structure of hexylcane. Another very important drug which comes under this synthetic agent is your Mepryl cane. Which one? Mepryl cane. So from its name, it is clear that me means methyl and pryl means 3 carbon species. So methyl and propyl, there are two groups present in this drug. So where these two groups are present? So let's see. Mepryl cane comes under the class ester of benzoic acid. So first we will draw the structure of benzoic acid. So this is your benzoic acid. And as I have already discussed, Me, methyl. So here one extra methyl group is there. Then again the structure is similar to this one. CH, not CH, C, CH3, and again CH3. Then here comes your NH, and on this NH again here comes your propyl, CH2, CH2 and CH3. So this is your methyl group, this is your first propyl and this is your second propyl. That's why its name is mepryl cane. Methyl and two propyl moieties are there. So this is your ester of benzoic acid. Now second class number 2. Class number 2 is your esters of PABA. Esters of PABA. PABA is what? PABA is nothing but para-amino benzoic acid. This is ortho-meta-para. This is para-amino benzoic acid. This is your PABA. So most of the drug included under ester of PABA is this basic skeleton, this one, para-amino benzoic acid. So the best example number 1. The first drug, the most simplest drug is benzocaine. The structure of benzocaine is this. Para position, there is amino group and it is a ester of para-amino benzoic acid. So this is your benzoic acid and ester. So benzocaine is the ester of what? Benzocaine is the ester of ethanol, C2H5. That's why its name is benzocaine. Now another example under this class is procaine. So pro, again here name indicate pro means 3. There are 3 special features or 3 special things, 3 carbon chain maybe, or 3 functional group. So what are these 3? So let's see. Again procaine is the ester of para-amino benzoic acid. So first of all we will draw NH2, this para-amino benzoic acid. Now what is pro? Pro means nothing but CH2, then N, and on this N there is again one ethyl group, which is the characteristic feature of local anesthetic, C2H5. So one ethylene or ethylene group, second ethyl group and third ethyl group. So there are 3 ethyl groups. That's why its name is procane. Now this is procane. Now next come another drug under this class is your another example, your tetracane. Which class? Tetracane. So tetracane again comes here. Tetra means 4. So what are these 4? So let's see the structure. 4. Tetracane comes under the class para-aminobenzoic acid. So here is the structure of para-aminobenzoic acid. This is the basic skeleton. Now what are the changes? Tetra means CH2, then N, CH3. So 1 carbon, 2 carbon, 3 carbon and 4 carbon. So this is tetra. But again here, what is present here? CH2 whole thrice CH3. So again this is also what? 4 carbon species, 3 methyl group and 4 methyl group. So again this is also tetra. What? 4 carbon species. So this is 4 carbon, this is again 4 carbon. That's why its name is tetracane. So these are all the example of esters of para-aminobenzoic acid. Now let's see the third class of local anesthetic. Acetanilide derivative. So what is acetanilide? Acetanilide is nothing but N-phenyl acetamide. N-phenyl acetamide. What is the structure of N-phenyl acetamide? So N-phenyl, this is phenyl ring, N-phenyl, this is your N-phenyl and acetamide, C double bond O CH 2 dash. So this is your N-phenyl acetamide. So most of the drug have this structure and which comes under this class, acetanilide. So what are the example of acetanilide containing drug? The first example is example number 1, xylocane. It is also known by the name lidocaine. It is also known by the name lignocaine. Xylocaine, lidocaine, lignocaine. These are all the name of same drug, xylocaine. So let's see what is the structure. So first of all, xylocaine comes under the class acetanilide. So first we will draw the structure of acetanilide. NH C double bond O CH2. Okay, and on N here what? Phenyl. This is your acetanilide, N-phenyl acetanilide. Now what is present over here? As it is mentioned in the name xylocane, xylocane has xylene ring, and xylene ring is what? Xylene ring is nothing but this structure. This is known by the name xylene. So in xylocane there are 2 methyl group, 1 methyl group over here and second methyl group over here. Now again what comes here? So again I have already discussed the characteristic group of all local anesthetic, diethyl amine. This is the structure of your xylocaine.